about 2 years ago, and it takes a huge load off your mind for the next week. And having videos is just the icing on the cake.
Who drove faster by the way?
Nobody. Insignificant changes. Insignificant changes. Which, it's one of those things. I swear to God, these metal kids. Yeah, it's because your neighbor is a metal kid and he drives fast. It doesn't mean it applies to everybody. I'm Philip Mars. I smoke 3 packs a day. Anyway, backside. Sorry. You see statistical illiteracy all the time. It tends to wear on you after a while. You guys will. How many? Some of you would be self-admit that I've ruined you in this class, in these 2 classes. You can't look at the news the same anymore. I ruined you. Imagine that compounded by 20 years.
But I'll never get another speeding ticket. Or be convicted.
So what you're saying is in 20 years.
Wait, why?
Because there's variance in your speedometer and there's variance.
Yeah, but they know that though. They know that.
And
And
if you get a ticket for
if there's variance in your speedometer, that's your responsibility, not theirs.
No, because manufacturers set it up. It's not guaranteed.
Good luck with that one, man. I had an ex-girlfriend back in the 80s that tried that defense. They're like, yeah, thanks, your car. So just saying, I got one anecdotal data point, but just saying. Plus, you have to prove that that variance is greater than the margin of error in the instrument, which it probably isn't. So anyway, good luck. Just saying, good luck. I'll help you with the math. I'll work the numbers with you if you want. I just can't guarantee any kind of result there. All right, tasks. We've decided what kind of test it was, right? We decided it was good. We decided it was 2 prop Z. So we know that we're testing the percentage of getting the task correct versus A and B, and the null is that they're the same. There's no difference at all in them. But we're trying to see if task B is easier than task A, and Zoe's fantastic question is, okay, what does that mean? That's why I put the second sentence in there. Does it seem like a higher percentage are getting B correct than A? Okay, so you can write that 2 different ways. You can write it literally like that. P sub B is bigger than P sub A. Or P sub A is less than P sub B.
What if you just like words?
That's fine. The percentage of those getting test B correct is, I'm not going to write that if you don't mind. That's fine too. Remember, I'm not forcing you to write these on the exam. If you want it in words, that's the key. The only reason I'm writing it now is to make sure when we get to the screen where we input the symbol, you know what symbol to put in. That's all I care about. Because if you put the wrong symbol in, you get the complementary p-value, which might give you exactly the opposite result that you want. Yeah, that's a problem. Let's go. Let's go. Stat test 2 prop Z is somewhere. Oh, it's right there, number 6. Okay. A bunch of you are getting domain errors on this one, to be expected. X is the successes and N is the trials. So for task A, it's 71 out of 110. The reason you're getting a domain error is because you can't have more successes than trials. So if you put 110 and 71, it's going to keep giving you error domain, because you can't. That's like the probability of rolling a 5 on a die is 6. No, it's 1/6. You see what I'm getting at there? So probability is successes over trials. I know that's a throwback to 243, I apologize. And 93 out of 120. All right. They're both over half, so it's kind of hard to see. One's about, 70%, one's like 75%. It's kind of hard to know which one's greater without running the tests. It's hard for me to see that. But I do think this one's higher than this one. That's what the hypothesis is, right? Task B should be higher than task A. So according to how I put these in, I'm going to pick this one, aren't I?
Yes.
I'm going to pick that one, which tells me that the probability of 2, that the percentage of 2 success is greater than the chance of 1. Fair enough? Everybody catch that? Yeah, and it all depends on what you put where, but I put it in like this. If you switch these, you switch the sign. Here we go. What do you think? Are more people getting task B correct? Well, I shouldn't say. Is a higher percentage of people getting task B correct? 3 points. Z equals negative 2.2-ish. P, 0.015. Nice conclusion. Give me a nice conclusion. Karen, go.
It appears task B is easier than task A.
Oh, that's perfect. I love that. She didn't use the percentage. That's okay, Zoe. But that's correct, because that implies that the percentage of those
Who did task B
is good. That's another way of saying it. But you can also just say it's easier, because the percentage is higher. Yeah, I like that. That's good. Fair? Fairish? Ashley, go, please.
I was confused at looking at this because it was asking if B was easier than A, but we got a p-value of less than 5, so I would think that it would be against that.
It's all within the null. The null always assumes there is no difference between A and B. So a
Okay.
small p-value means it's hard to believe there is no difference,
Okay, all
which
right.
means there is a difference, and then this tells us the difference leans towards B being easier. I know it's a little bit tricky, but that's why I always have to compare it. Null is always status quo. Null always says everything's the same as it always has been. Null says, I'm skeptical. I don't think there's any difference between A and B. So a small p-value means not much agreement with that belief. P-value is looking at your data and seeing how your data connects to your null hypothesis. The smaller the p-value, the less connection there is. I'm helping you answer one of your take-homes. I apologize. Actually, don't apologize.
What was that?
Remember Pam Purdue? Oh, it's on video, that's true. Pam Purdue says a p-value is the chance your null hypothesis is correct. That's crap! That's not true. It's the percentage of agreement, if you will, between your data and the null. The less agreement, the smaller the p-value. And if there's no agreement between your data and your null hypothesis, that means there has to be agreement between your data and some alternate hypothesis somewhere else. We don't know where, but somewhere else. Is that fair? If we're most likely not on the equals curve, we're most likely on some other curve somewhere else. Cool? Good. We got 10 minutes. Let's knock out one more. And we know